Hello, today we're going to be dealing with electrostatics, and I'm trying out a tablet over here, so excuse if it doesn't look as good as it usually is. I'm trying this out for convenience. Right, so looking at we're first going to be looking at your one-dimensional electrostatics, but first let's look at a formula. F is equal here to K charge 1 times charge 2 over R squared over here. Now, if over here the SI unit is going to be, I'm sure you know already, newtons, then this over here is going to be charge 1 as well as charge 2 will both be in coulombs, and R stands for your distance which will be in meters over here. And K, however, K is going to be your constant, which is 9 times 10 to the power of 9 over there. That will be your newtons per meter coulomb. All right, but now that we've got this, it's important to also understand the definition. And generally, we can get our definitions from our formula over there. And Coulomb's law states that the magnitude of the electrostatic force between 2 point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance. So what they're saying is, when we're looking at electroforces over here, our force between two charges, so our force over here between two charges, which is going to be Q1 and Q2, our force between these two charges is directly proportional, which means if my charges over here increase, my force will also increase. If my charges decrease, my force will ultimately also decrease. But my distance is inversely proportional, which means if this over here gets bigger, if my distance increases, how my force is going to decrease. But if my distance decreases, my force will then increase. So that is your definition over there for Coulomb's law. I'll repeat it again. Your Coulomb's law states that the magnitude of the electrostatic force between the 2 points here is your Q1 and Q2, between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. All right, and there you go. That is what we're going to look at when trying to complete this one over here. All right, so I've got 3 little balls over here with different charges, and this sign looks a bit weird, but next to the -4 as well as the 6 and the -8, it says over there micro coulombs. The one that looks like a funny upside down H, right? That is going to be millicoulombs over here. Ooh. Right, millicoulombs. Right, so determine the net electrostatic force on K. Right, so here's K, this is K, that is... Apologies for that. So, I know I've done a lot over here, but looking at all of this, let's see, let's just do this here. Okay, looking at all this here, I've substituted everything in here. This is my value for J, this one here, this is my value for K, and then this is going to be my distance over here, my R. Now, why is it a positive and not a negative for that 4 over there? Because we're not too worried about that. We're just calculating what the charge is between these two over here. Between this and this, we're trying to calculate what is my charge going to be. And we can see that my charge is going to be 240 newtons to the left over there. Now, why do I know it's going to the left? Because it's my positive going towards my negative side over there. And that is the reason why I know it's going to be like that. So if I try and do the next one, let's try, oh yes, and the reason this is -3, don't forget, because this is it, millimeters over here. And remember, millimeters needs to be converted into meters. Right, so let's try out another one. Let's go with black again. Right, so let's try L onto K. So I'm going to say here F is equal to, once again, I'm going to say K. This time I'm going to say QL, and Q over here for, let's go with K. Then I'm going to substitute it in. 9 times 10 to the power of 9. QL, what's my charge of L? It's 8. Then it's going to be 8 times 10 to the power of -6. Why is it -6? Because it is over here, you can see it is microcoulombs. And then I'm going to have, again, K, which is going to, K, which is 6. So 6 times 10 to the power of -6 as well. And what is my distance over here? You can see it's 60. So this time I'm going to say 60 times 10 to the power of -3. Why? Because there's 1,000 millimeters in 1 meter. And this is all going to be to the power of 2 over there. My final answer there is going to be 120 newtons, but this time it's going to be towards L. Now, I can see now I've got towards L, and this one's left, so towards J. Alright, so that one's left. Now, because this one is going towards the left, right? Let me use a different color over here. Let's go with red, right? Because, is it red? Yeah. Because I'm saying this one is to my left, notice which way I said is positive. I said that right is going to be, and if this is left, then I'm going to treat that as a negative. And because this is going towards the L, you can see there it's going towards the L, I'm going to take this right-hand side as positive. So I'm going to say this is a positive 220 newtons. Now, I still need to add all of this up. So what am I going to do? I've got my two values there. Let's see, I've got my two values there. Now I can add them together. So I'm going to say the force on, let's go let's go with F net. Wow. F net on K. It's going to equal over here my, let's go with -240 plus 120 newtons over here. It's going to all give me -120 newtons. Now, because I know it's 120 newtons, and because I also know that it's negative, I know that it is going to be 120 newtons over there left towards J. So now that I know that it's going towards J, I'm sorted over there. I know now that based off everything that we have seen from in terms of your negatives, remember, it's going to go from right to left. My K is going to go from the K to the J, and then from K to my L, based off which direction my negatives are. I have stated which way is positive. I said take right as positive, and I did my calculations. I know I just got a general 240, but I know because my K is going from K to J, it's going to be a -240, and this one is going to be from K to L, it's going to be a positive 120. Then I add those two together. My overall answer was a negative. So overall, from all of this that's going on over there, it is generally just moving towards the left, 120 newtons on the left towards J. Right, that is your first one in terms of one direction. Right, thank you.